Hello and welcome to Math with Mrs. Becker. Today in Pre-Calculus, we are doing some practice questions to help you to prepare for the Chapter 2 test. Starting off in 2.1, we were solving equations using technology and graphing. We are using Desmos.com. Remember, that's that free graphing calculator app. If you want to solve equations like we see in examples 1 and 2, what we have to do is go on to Desmos. You graph each side of the equation separately. So things to remember, you do not actually type the equal sign into Desmos. One side I will put x cubed plus 2x squared. Graph that. Then enter a new function and type 2x plus 2. What we're looking for is where does the intersection occur? Where the intersection occurs, those x values, because we're trying to solve for x, those x values are your solutions. They want us to round everything to the 100th, which remember that means that you have a decimal and you can have 2 points after. So let's go for it. So here's Desmos.com. The first side of my equation is x to the power of 3 plus 2x squared. Okay, that's one side. Once you're done with one side, go ahead and tap underneath. Notice, again, I did not type the equals. This side is 2x plus 2. What you'll need to do on the exam is be able to sketch, okay? So it says sketch the screen. So my first was a fun little cubic section. And again, sketch just means have the general shape. It does not have to be perfect. Then what happened is we had a line go through that. And notice this line touches at 1, 2, 3 locations. So however many intersections you have, that's how many solutions we have. So again, you sketch your screen so you get the general shape. Then you state your solutions rounded to the 100th. Our solutions are the x values for the intersection. Here it's 1.17. Here it's negative 0.689, so the 9 would bump that to, the 9 would bump the 8 to a 9, so it's negative 0.69. Here, this 1 is not enough to bump that 8, so it would be negative 2.48. There is one example. Let's make sure that we've totally got this, and let's do one more. Again, if I am trying to use graphing technology to solve an equation like this, step 1, you go into Desmos.com, so let me get rid of the previous graph, and you just type in one side of the equation, x to the power of 4 plus x to the power of 3 minus 5x squared. That's one side. Now I tap underneath and I type in the other side, negative 2x minus 3. What you'll be asked to do is sketch, okay? So sketch, just have the general shape. Do not worry too much about it being perfect. If you're looking at my graphs, they are far from perfect. I'll go ahead and this is way down and way up. Okay, so there was the first side. Then what happened is I went ahead and graphed the second one and we got a line like this. Okay, so you just kind of sketch what it looks like. Notice how many intersection points we have, where in my case I have a blue curve and a green line. Where do they intersect? I see 2 intersection points. Then you just go ahead and tap on those intersection points. They will give you the ordered pair. Your solution are the x values, because what we're doing here is figuring out what values of x could I put into here to make both sides have the same value. Well, one of those is negative 2.86. Another one is negative 0.59. Okay, so that is what you need to be able to do for Chapter 2, Section 1. Be comfortable with Desmos, know how to solve equations by looking for intersections, rounding to the 100th, and being able to realize that these intersection points, they give you the x values that you can fill into the equation to make a true statement. Now 2.2, we were solving quadratics using algebra. So things like the quadratic formula and factoring. So that's what we will go ahead and do now. If I want to solve by factoring, step 1, you want the set equal to 0. So I'm going to go ahead and minus the 5 to the other side. So 3x squared minus 2x minus 5 equals 0. What I need to do is factor 1, 2, 3 terms. 3 terms is always the multiply add method. because there is a number in the front of my squared term, I go ahead and I take the first term times the last term. Positive 3 times negative 5 is negative 15. The same two numbers have to add to the middle, which is a negative 2. For us, that ends up being negative 5 and 3. Negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. Because of the value in front of the squared term, these two terms replace the middle. The first term stays and the last term stays. The middle term had an x, so when I put in the negative 5, I need to give it an x. When I put in a positive 3, I need to give that an x. Now we have 4 terms, so if we are factoring, you do what's called the grouping method. When I group the first 2 terms, I notice that they both have an x. I can take the x out, giving me 3x minus 5. Notice that this is already 3x minus 5. With grouping, you always have to take out a value. So you ask yourself, what can I divide 3x minus 5 by and have it not change? Well, that would be a positive 1. Because if you divide by positive 1, it's not going to change anything. This matches this, so we know that we factored it correctly. Whatever you divided out, in our case it was an x and a positive 1, that forms a group. The factors that match, they form a group. Now if I want to solve, you set each factor separately equal to 0. So if I take x plus 1 and I set it equal to 0, I would minus 1. 0 minus 1 is negative 1. Now if I take 3x minus 5 and I set that equal to 0, here I add 5, so it'd be 3x equals 5, divide by 3, so I have 5/3. Okay, quadratic formula. Same idea as when you're factoring. You want to make sure that it's set equal to 0 and it's in standard form. So step 1, I need to move that 7. 5x squared plus 6x minus 7 equals 0. A is always the value in front of the squared term, so it's a 5. B is always the value in front of the single variable. In this case, it's a 6. C is your constant at the end. To find the value that goes underneath the square root, you'd find what's called the discriminant. It's b squared minus 4ac. B is 6, so 6 squared minus 4 times a is 5 times c is negative 7. If I go ahead and calculate this, 6 squared minus 4 times 5 times negative 7, I have 176. Let's see if that's a perfect square. It is not. So we want to see if we can break that down at all. Because 176, is it divisible by 3? Nope. Is it divisible by 2? Heck yeah. So it is 2 times 88. And 88 is 8 times 11. And 8 is 2 times 4. And 4 is 2 times 2. So the square root of 176, I can cross off 2 2's, I get to write a 2. I can cross off 2 2's, I get to write a 2. 11 cannot be crossed off. On the outside, I have 2 times 2, so this is 4 square roots of 11. And let's say you're ever wondering if you did that correctly. What I could do is if I take the square root of 176, it's 13.266, okay? If I take 4 times the square root of 11, it's 13.266. So we did get the same thing. So that's just one way that you can check your solution. Back to the quadratic. X equals negative b, so it's negative 6, plus or minus b squared minus 4ac underneath the radical. We already simplified it to 4 square roots of 11 all over 2a. A is a 5. 2 times 5 is 10. Your last step. You look at any of the values that are not underneath the radical. If you can simplify those by dividing them all by the same number, we have to. All of these numbers and what I'm looking at are the 6, the 4, and the 10. They're all divisible by 2. So my solution would be negative 6 divided by 2 becomes a negative 3. Plus or minus 4 divided by 2 is 2. Square roots of 11 over 10 divided by 2 is 5. Here are your 2 solutions. Remember, there are 2 solutions because one solution you are adding the values in the numerator over the denominator. Your other solution, you are subtracting the numbers in the numerator over the denominator. Let's keep on going. The backside. If we are trying to solve by factoring, 1, 2, 3 terms, that is the multiply add method. There is not a number in the front this time, so we are looking for two numbers that multiply to the last term and add to the middle. In our case, it would be -2 and -9. Negative times a negative is a positive. 2 times 9 is 18. -2 minus 9 more is a -11. So when I factor it, it's x minus 2, x minus 9 equals 0. To solve, you take each group separately and set it equal to 0. Here I add 2. 0 plus 2 is 2. Here I add 9. 0 plus 9 is 9. Okay, those are really good examples of what you'll see on the exam. That comes from Chapter 2, Section 2. Now, 2.3, this was the section with all the story problems. Okay, here's an example of what you might see. The width of a rectangle is 3 times the height. So right away, I go ahead and draw it. We have a rectangle. The width is 3 times the height. Well, we don't know what the height is. So I'm going to say, okay, the height is h. The width is 3 times that. So there's our diagram. If it has an area, meaning how much can go inside of that space, okay? If it has an area of 60.75 square feet, what are the dimensions? Remember, the area of a rectangle, you take length times width. So I would take 3h times h, and the area is 60.75. Well, 3h times h is 3h squared equals 60.75. I need to solve for h. So I divide both sides by 3. H squared equals, if I go ahead and take 60.75 divided by 3, I get 20.25. To solve for h, which is the height of a rectangle, I take the square root of each side. Square root cancels a square, so h equals plus or minus. Take the square root of 20.25, and I get 4.5. Now, looking at the fact that this is a story problem and h represents the height of a rectangle, you can't have a negative dimension. So h is 4.5 and it's feet. I know it's feet just because the area was square feet. So this is 4.5 feet. The width is 3 times h. So it's 3 times 4.5. If I take 3 times 4.5, I have 13.5, and again, the label is feet. So there's an example of what you will see on the exam from 2.3. Now, 2.4, we spent a few days on because we were learning how to solve various types of equations, things like absolute value and radicals and fractions. So looking at number 7, the first thing to remember is that absolute value means that you are traveling on a number line. It is possible to travel to both the right and it is possible to travel to the left. Because of that, you need to turn any absolute value equation into 2. One indicates going to the right, one indicates going to the left. So when I show that I'm going to the right, whatever was in the absolute value bars, we have a little plus sign on the outside. Okay, we're going in the positive direction, the right. When we're going to the left, whatever was in the absolute value bars, we have a negative in front because that indicates, hey, we're going in the negative direction. Well, if I distribute a positive, it's not going to change anything. Positive times x is x. Positive times a positive stays a positive 2. So that's why oftentimes they tell you just to drop the bars and rewrite it the way it is. The reason why that works is because technically you're distributing a positive, which doesn't change anything. Now I solve. If I go ahead and minus 2, 4 minus 2 is 2. And it says just solve. Let's go ahead here, distribute the negative. Negative x minus 2 equals 4. If I'm solving, I add 2. So negative x equals 6. Divide both sides by -1. Positive divided by a negative is a negative. 6 divided by 1 is 6. They just asked us to solve, not solve and check. So you get to go ahead and be done. Okay, next one, when we looked at radicals, if you want to cancel a square root, the inverse operation of a square root is a square. What you do to one side of an equation, you have to do to the other. So you square the square root, it cancels the symbol, but it does not change what's underneath. 0 squared is 0. I know I need to find two solutions here because I have a degree of 2. I can factor, multiply, add method. Two numbers that multiply to the last term, -2, and add to a -1. Well, that's -2 and 1 because -2 times 1 is -2. -2 plus 1 is -1. So what I have to do is go ahead and factor that. X minus 2, x plus 1 equals 0. To solve, you take each factor separately, set it equal to 0. To get x by itself here, I would add 2. 0 plus 2 is 2. To get x by itself here, I'd minus 1. 0 minus 1 is -1. You just solved it. Next one, number 9. If you are solving and you need to cancel a cubic root, in order to cancel a cubic root, you need to cube each side. Cubic root cancels a cube. Whatever's underneath does not change. So it stays 1 minus x squared. -2 cubed. If I take -2 times -2 times -2, it's -8. Now what I need to do is go ahead and get the set equal to 0. If I add 8 to each side, I have 9 minus x squared. I can do the difference of squares here. Because I have two terms, there is a minus in between. I can take the square root of 9 and get a 3. I can take the square root of x squared and get an x. So this is 3 plus x, 3 minus x. It's okay that the number comes first because the number came first in our equation. Okay, so you have to keep it in the order that it is here. That's why it's 3 plus x, 3 minus x. Now to solve, 3 plus x equals 0, 3 minus x equals 0. If I want to get x by itself, I'd minus 3. 0 minus 3 is -3. Here, I would minus 3. Negative x equals a -3. To cancel that negative, you divide both sides by a -1. Negative divided by a negative is a positive. 3 divided by 1 is 3. So our solutions are -3 and +3. Last page of the review, guys. This is interval notation. Things to remember here. When you have rounded brackets, it's an open circle. If you have squared brackets, it's a filled in circle. Infinity, if you have an arrow going all the way to the right, or negative infinity, you have an arrow going all the way to the left. The brackets will always be rounded, okay? If I am graphing this interval on a number line, I have to go from -4 to 7. So -4, -3, -2, -1, 0. 1, 2, 3, 4, 5, 6, 7. In interval notation, they always tell you the lowest value. So where is your starting point? We have a circle on -4. It's a squared bracket, so it's a filled in circle. Our interval where the shading ends is at 7. It is a rounded edge, so it's an open circle. Interval notation means you shade whatever is inside. Okay, solve the inequality. Graph your solutions on a number line and then write it as an interval. Well, the first thing I notice here is I have parentheses. You always want to simplify both sides of an equation or an inequality before you start to solve. So here I'm going to go ahead and distribute. -3 times x makes this -3x. -3 times -4 is a +12, greater than or equal to 5 plus x. Okay, no more parentheses. I can't combine any like terms on the single sides of the inequality to make it shorter. So this is what we've got. You cannot have x's on both sides. So if I want to move the 3x to this side to cancel a -3x, I add 3x. 12 is greater than or equal to 5 plus 1x plus 3x makes 4x. Go ahead and minus 5 to each side. Well, 12 minus 5 is 7, greater than or equal to 4x. Now what I want to do is go ahead and get x by itself, so I need to divide both sides by 4. 7 divided by 4 is 1.75. My symbol is greater than or equal to x. Okay, so that is my solution. Now you graph the solution on a number line. So I have 1.75. That's in between 1 and 2. This is an indicator of a filled in circle. So I have a filled in circle in between 1 and 2. If I look and see what the symbol is doing to the letter, it's not eating the letter. That means that we're looking at smaller values, so I shade to the left. So we graphed it on a number line. Now write it in interval notation. Interval notation, you have to go left to right. The furthest thing to the left is an arrow. So that means I'm going to negative infinity. The furthest thing to the right is a filled in circle on 1.75. This interval describes the shading on the graph. So it's really cool. We can have inequalities, interval notation, and a number line representing the same solution. Okay, the next one. If you ever have an inequality where you see two inequality symbols, what's happening here is they're sharing the middle. The middle has to be part of both inequalities. So when I split it into 2, it goes -4 is less than the whole center, 2x plus 5. Now I start at the center. 2x plus 5 is less than 9. One thing to make sure is that you do include the full center, whatever's in between the two symbols. That full expression has to be part of both inequalities. Now this is called a compound inequality, meaning you have to solve two different inequalities to get your solution. Here I minus 5. -4 minus 5 is -9 is less than 2x. Divide both sides by 2. -9 divided by 2 is -4.5 is less than x. Now I come over here and solve. Minus 5. So 2x is less than 9 minus 5 is 4. Divide both sides by 2. 4 divided by 2 is 2. Graph the solutions. So I'm going to say, well, this is 0, this is 1, this is 2, -1, -2, -3, -4, -5. So I have an open circle on -4.5. I have an open circle on 2. Now when I look at this, the x, if I draw that little symbol, remember if it's eating the letter, you go to the right. So from this circle, we go to the right. Here it's not eating the letter, it's x is less than 2, so you go to the left. So these two, because we're shading in the direction of the other circle, it shows us that we shade in between the two. Another way to know that you're shading in between is you are sharing a piece that goes in between those two inequalities. So once you have your two solutions, you graph the circles, shade in between. Last section. If you are solving a graphing inequality, again, we're going back to Desmos.com. So hopefully you kept that. Handy. Let's go ahead and look at that. So Desmos.com. Write the inequality in a way that you can use the x-axis to determine your solution. That means you set it equal to 0 or greater than or less than symbol with a 0. Then we sketch the graph. So here, for some reason, the exponents did not print as exponents. This is x to the power of 4 plus 10x to the power of 3 plus 21x squared. That is one expression. If I want to use the x-axis, what I need to do is be able to minus a full expression. So I'm taking 40x plus 80 and moving it over there. My symbol is less than, but now it would be a 0. Okay, so that's what that means. And this was the last thing that we did for the chapter. So I take this side, move it over. This is a 0. So what I can do is use the x-axis. Now we graph this. You don't put in your less than or 0. So just like when we were doing 2.1, you don't put in the equal sign. So my first expression, one side was x to the power of 4 plus 10x to the power of 3 plus 21x squared. That was one side. Minus, open a parenthesis, 40x plus 80. Now, I can tell this is kind of hard to see the picture. Remember, you always have that window. I'm going to go x's, let's go like -6 to 6. We'll see if that works. You can always change it. Y's, let's go -100 to 100. Okay, so I can kind of see this. That actually worked out pretty darn good. Because we're using the x-axis, we got it set equal to 0. Here are the values that we'll be using for the interval, okay? They are the x values. We want to know when this is less than. That means that when is it below? Well, here's when it's below. Okay, so the x value, it hits 0 and negative 1.53. We're not including that value because we don't want it to be less than or equal to. We just want it to be less than. So that's why that is a rounded circle. Then I keep going. It's below, it's below, it's below, it's below. It hits 0 again at 1.892. So that means it stayed below 0 up until then. So it's a rounded edge. So using the graph and the x-axis, we could tell where this was less than 0, just means it's below the x-axis. Your test is tomorrow, but if you understand what we were doing today, you will be just fine. Hope you guys have a great day. I'll talk to you soon.